Ladies and gentlemen, welcome to this audio slide presentation. I am Matija Jaworski and will in the next few minutes present to you our scientific article titled Frequency Characteristics of Magnetostriction in Electrical Steel related to the structural vibrations. The article was published in IEEE Transactions on Magnetics in December 2012. This research deals with experimental characterization of the alternating magnetostriction phenomena as one of the root sources of noise in electrical steel components of electrical devices. The focus is on the structural dynamics of the experimental setup as it interacts with the test sample. Namely, due to dynamical coupling, the characterization of magnetostriction, especially the one in the frequency domain, can give the wrong result. This aspect has already been reported in several preceding researches. Accordingly, our research is said to give a clear picture on the dynamical coupling and therefore enable an undistorted measurement. When considering a common experimental setup with the test sample clamped at one end and attached to the linear guides at the other, its in-plane dynamics can be represented with a single degree of freedom system. The response due to magnetostriction depends on the scale of the excitation phenomenon, as well as on the dynamical coupling between the sample and the setup. The latter presents a disturbance to the measurement as it artificially scales the response. This effect is characterized by the dynamic magnification factor beta presented in the figure. The measurement error is denoted as eta. Similar conclusions about the detrimental effect of the dynamical coupling on the measurement as for the in-plane direction can be deduced for the out-of-plane direction as well. With regards to the presented dynamical effects, a new test sample and experimental setup were proposed for characterization of magnetostriction resulting from a 50 Hz alternating magnetic field. The dimensions of the test sample were set specifically to assure sub-resonant operation during measurement. In-plane and out-of-plane dynamics of the system were analyzed theoretically as well as experimentally. While the experimental setup demonstrated non-resonant behavior in the range of its intended use, an alternation was made in order to display the effect of the out-of-plane resonance. The length of the test sample was increased, therefore lowering the first out-of-plane natural frequency to 314 Hz. Magnetic excitation was applied at frequencies ranging from 50 to 200 Hz and resulting in fundamental magnetostriction harmonic of 100 to 400 Hz. Response was measured in the in-plane and the out-of-plane direction. In contrast to the control measurement, the altered geometry of the sample resulted in mechanical resonance, which proved detrimental to the quality of the measurement. The article presents theoretical background on dynamical coupling of the test sample with the experimental setup, allowing a proper setup design for an accurate magnetostriction characterization. The introduced test sample and method were shown to be appropriate for characterization of magnetostriction resulting from a 50 Hz alternating magnetic field. The effect of the dynamical coupling on the measurement was demonstrated experimentally. A systematic research on a series of excitation frequencies showed accurate magnetostriction measurement is not possible when mechanical resonance is present.